Okay, so to anyone who's watching this, welcome to today's session. We're going to talk about equations, and most of the stuff we're going to cover should already be covered partially before you join IB, I presume. And like one of the okay, so we're going to start with power equations. So power equations literally only means if there's x to the power of n, then the result is k. That's what you call as power equations. I don't recall that you need to specifically remember this term. You just need to know this, and you just need to know its general properties along with this format. So basically, in this format, you need to remember that, for example, if you have x to the power of 2 equals to k, then that means that if you want to turn this power into the other side and turn x into the subject, then you're going to have to square root the k. But you mustn't forget that if this is the case, the result can be positive or negative. Because as you can see, if you have a positive number, for example 1, and then you square it, it becomes positive. But then if you also have a negative number and then you square it, it becomes a positive number. And it always happens when the exponent is an even number. Like for example, 2 minus 2 times minus 2 times minus 2 times minus 2. This is equal to minus 2 to the power of 4. And since you have negative, 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 it becomes a positive result. And 2 to the power of 4, I think, is 16. So that would be 16. And that would be the same result as this. This also equals to 16. And this is why there's this property that you have to know. And then if x to the power of n equals k, if x equals to 0, then k obviously equals to 0. Because any 0 that you have, when you have any power on 0, it results in 0. Because you're multiplying 0 by 0. You don't get any, you can't get 1 out of this. It only applies if you have like 2 to the power of 0, then you get 1. And then if x is, for example, some non-real number, in this case, in later cases, you'll learn that some of the non-real numbers that we're going to be learning is the imaginary number. For example, if x is an imaginary number, then k, then if you add a power to this number, then k is equal to something less than 0. And I mean, k just doesn't exist in a way because of x non-real existence. But then if x to the power of n, if this is an odd number, then if you have an odd number equals to k, then a way to find x is just to square root the k with the power that you have. Okay, I'm so sorry, but let me correct that. So basically, if you have a non-real solution for x, for example, if x is an imaginary number, and then you have the power of an even number. For example, you have the power of 2, you have the power of 4, or you have power of 6, this will give you a negative result. For example, in this case, it gives you -1 because basically what's going on, I'll briefly cover this. I, the imaginary number, is square root of -1. And if you multiply square root of -1 to itself, then it gets you -1. So the number is less than 0. But then for this one, you get -1 times -1, which equals to 1. And I I have okay, let's just say that in this case the no real solution is just like syntax error or math error. So I don't because this is different things. So I don't know why it's like that, but it is. And then now on to the next one. We have equations in factored form. So when they refer to the word factor, usually the equations would be in forms of brackets and numbers. Usually you can see it's something like this, or for example, something like this, or anything with like at least one bracket, x plus y, and some multiply variable like x plus 5, or wait, sorry, no, with like all sorts of multiplied values. This is called factored form. But if you add like if you have addition or subtraction in added in the factored form, for example, like this, then this is no longer a factored form. And usually the common factored form that you can find is equal to 0. And this is usually very useful because by turning it into equal to 0, you can easily find the value of x or the value of y. And this is usually what happens when you're solving for quadratic equations, like when you do factorization or when you do completing the squares. And as you may know, oh geez, sorry. Okay, so as you may know, factored equations, for example, like this one, usually turns into a quadratic equation. And how you do that is that you multiply it 1 by 1, and this gives you x squared plus 5x plus 3x plus 15. X squared plus 8x plus 15. And this usually gives you the common quadratic equation form in this, like this. And this is a very important form you must always know because you're going to use it a lot in future questions. You don't necessarily have to remember these terms, but you do have to know like the common form of this. So oftentimes in exam, they're going to ask you to find x. to solve the x in this equation. And there are several ways to do it. You can do the factorization, you can complete the square, or you can use quadratic formulas. Honestly, quadratic formulas in a way is actually complicated. Is actually sourced from the algebraic way to move x into like one side of the equation and move everything else to the other. And I'll probably like just briefly cover it up so it can give you like an intuition or an understanding of
Basically, the quadratic formula is derived
yeah.
using completing the square for the general form.
It's generally derived from completing the square, and like you don't need to know how to derive it. It's just helpful for you to like understand why the equation exists. Okay, so I think like a better way to show this is to work on examples. Wait, let me. Okay, let me look for examples for factorization. That is. Okay, so for example, if you have x squared minus 5x plus 6 equals to 0, the way you do factorization is that you try to find the values which can you try to like reverse engineer this thing to turn it into factored forms. And the like one of the ways you can do it is by guessing it, like by trying to test out some of the values that you can do. For example, so usually in the end part, you're gonna have to multiply each other. Multiply the numbers in the last parts to itself, so you can find like the last value. And from this, you can try to figure out the multiplications of numbers which results in 6. So usually to multiply 6, you have 1 times 5, you have 2 times 3, sorry, 1 times 6 and 2 times 3, and I think these are the two values that you can have. And then to figure out whether it applies to this, then you have to look for this value. So how I usually do it is like I try to figure out the values that can be added together if this one is positive. Because if this one is positive, that means that it's gonna be like positive times positive or negative times negative. So since this is negative 5x, the plausible explanation for these values would be negative 2 times negative 3. You get me? Because you're gonna have like if you think about how this thing works, you're gonna have to multiply this by this and then this by this. So you're gonna have minus 3x minus 2x. So you're gonna have to find the two values that add up to this value. And then for this one you're gonna have to find the two values that multiply in result of this value. I have no idea if my explanation for that is clear, but that's usually how I do it. Okay, so after factorization, we have completing the square. An example of completing the square would be to have, let's just say, x squared plus 4x plus 1. Okay, so in this case, you don't, it is not possible to try to factorize it because this is 1 and this is 4. And you have, if you try to like get the combinations of number you can multiply by, it's only 1 and 1. But for this 4 value, you can't have 1 plus 1 equals to 4. That doesn't work. So to figure out the answer, to figure out the answer to x, you're going to have to complete the square. And by completing the square, I mean to kind of like separate this value from this. You don't literally separate it, but you kind of separate it by manipulating the algebra that you have. And so you're going to have to make a hypothetical square, as if like, what value do you need to put in here in order to make x plus something square plus 1. So so your goal here is to try to make a square. And how you do that is by looking at this value. So this value is 4, right? How you get the middle part is if you have something like, let's just say, x plus y times x plus y squared, you're gonna have x squared plus 2xy plus y squared. And this shows that if you have like y squared here, the value of this part is 2y. And to find, that means that if you want to look for the answer of this, you're going to have to divide the result of this by 2 to get y, and then square it by 2, and you get the value which helps you look for helps you like contract it back into the factored form of it. But since this is an equation, you cannot just add 2 to the power of 2, because you have to balance the equation. And how you deal with balancing the equation is you add a minus 2 to the power of 2. But then you kind of indirectly separate it by adding a bracket around this part. So you can factorize it and still have this. So that results in x plus 2 to the power of 2 plus 1 minus 2 to the power of 2, that is 4, equals to 0. So that's x plus 2 to the power of 2 minus 3 equals to 0. X plus 2 to the power of 2 equals to 3. And then from from then on, to find x, you just easily do x equals to, x plus 2 equals to square root of 3, because you're gonna move the square root here, and then you don't forget to add plus minus, since because of this, and then now you move this value so that x becomes the subject. Plus minus 3 minus 2. So that's the answer. Okay, so same question. But if you're very lazy to do all those steps, hold up, did I? X plus 4x plus 1, I think, yeah. If you're very lazy to like do all those complicated stuff, you can always insert in the formula of minus b plus minus b squared minus 4ac over 2a. And this is basically just a from ax plus bx plus c equals to 0. You see, like, just insert these values, and then you easily get the answer. In this case, is 4 plus minus 4 squared minus 4, 1, c is 1 over 2a is minus 4 plus minus 16 minus 4, 12 over 2. So that is minus 4 plus minus 12 is 3 times 4. So you can take this out, since this can become 2 square root of 3 over 2. And then since this is 2 to 4, you can divide these by 2, and that results in minus 2 plus minus square root of 3. So you get the same result as this. And then the third option would be to use technology. So you can always use your GDC to get the root of the quadratic equation. It also applies the same with polynomials. You can like literally just pull out your calculator and then write down this, and you can get the value. Or another option for the calculator is that you can graph this. You can graph this equation and find the value of x. For example, this is minus 2 squared speed. Okay, graphing it takes a while, so let's just assume the graph is like this. Okay, so you insert this in your calculator, and then, for example, you get this graph. I don't know if it's correct or not. This is just an example. And then after you get this graph, you see the x-intercepts, and these are gonna be your the x value of the x-intercept, which crosses the x-axis, is going to be the same answer as this. It's as easy as that. Okay, so now you have discriminants. Discriminants are usually written in delta, or its formula is in form of b squared minus 4ac. And the reason why it's this is because of the formula of b minus b plus minus square root of b squared minus 4ac to a. So if you have these numbers as a positive number or any form of number, then you have a normal two-root answer because it's plus minus. But if the square root of b squared minus 4ac results in a 0, then the plus minus sign is gone and there's going to be only one answer, since let's just say b squared minus 4ac equals to 0. Then you have this. So this results in minus b over 2a. And this is going to be your only solution for the only x solution for the quadratic equation, because there's no more of the plus minus options. But then if your answer is less than 0, let's just say -1 or square root of -2, then logically speaking, if you insert this into your calculator, then the result wouldn't exist. So there's not going to be a solution. This can also be visualized from the graphs. So basically, if you have a discriminant that is over 0, it's going to look like this. But then if you have a discriminant with a 0, then it pretty much looks something like this. Only one point touching the x-axis. For this one, it's 2, right? But then if the discriminant is if it's not a real root or not a real solution, then there's no solution because it doesn't touch. Okay, and then next up we have the sum of product of roots. So assuming that we have two roots. For example, like if you have something like this, your root would be -1 and 2, because it's like assuming that x plus 1 equals to 0, and you have to look for the x value. If you have these two roots, you have the property of the first root plus the second root equals to minus b per 2a minus b per a. Well, multiplying those roots would result in c over a. So I'm going to briefly explain why, because in my personal experience, I had teachers explain this and never tell me why, and it's like kind of frustrating because like, where does this come from? And it's not easy to remember. So since that's the case, let's just assume that x, let's just say the root of the first and the second is in the term of a and b. Wait, no, let's not. That's going to be confusing. Let's just say it's an alpha and beta. This is x1, this is x2. So that's going to be x minus alpha and x minus beta, right? And this is equal to ax squared plus bx plus c. Remember the quadratic equation. And if you see this, there's something problematic about this. Can you guys guess what it is? And why there's something problematic about it?
A?
Yep, it's the A. So to make this factorized form, you would need the x to equal x squared to half 1, right? It's equal to 1, not an A. And to deal with that, we can add an A right here to make it so that we have an A and A result. And then after that we can expand this, and you would get x squared minus 2 alpha b plus alpha beta equals to a x squared plus bx plus c. And if you want a very obvious way to eliminate this a, the easy way to it is just move this to the other side. So you turn this into this equation divided by a, and that would result in x squared minus 2 alpha. Wait, this is. Oh wait, sorry. This should have been. This should be a x squared minus. Wait, hold up. X squared, ax squared minus alpha x minus beta x plus alpha beta equals to ax squared plus bx plus c. And again, we're going to move this here to make it easy. So you get x squared minus alpha plus beta x plus alpha beta equals to x squared plus b over ax plus c over ax. So wait, no, c over a, I'm so sorry. So if you see from this comparison, we can compare since this is already the same in the first part, we can compare the coefficients of x and the last value of it. And this means that it is possible to say that minus alpha plus beta equals to b over a, well, alpha times beta equals to c over a. If you move this, alpha plus beta equals to minus b over a, these two results in these two properties. So if you don't remember these two equations, you can always pull this out for like a little short exercise in algebra, so you don't forget. It's a good way to remind you of how this exists. Or another literal way to do it is to do, for example, if we have this equation, right? You have the quadratic equation, and this results in x. So let's just say, again, x1 equals to alpha, and then x2 equals to beta. Alpha would be minus b plus b squared minus 4ac over would be, yeah, only plus 2a, and then beta would be minus b minus b squared minus 4ac over 2a. So if we add these two up, so let's just say alpha plus beta, that would be minus b plus square root of b squared is 4ac over 2a plus minus b minus b squared over 2ac over 2a, right? And that would result in minus 2b over 2a. And since this is plus, this is the other part is minus. This is both gone, so now you get minus b over a. And it goes the same with alpha times beta. If you insert this equation, you're going to eliminate the wait, let me just draw it. So if you have alpha times beta, you're gonna have minus b plus square root of 4a b squared is 4ac over 2a times minus b minus b squared minus 4ac over 2a, and that would result in b squared minus b squared minus 4ac, because let's just assume that this is like one variable. This is one variable, and you know if you have the like x plus y times x minus y, this results in x squared minus y squared. So so this thing becomes square root of bx minus 4ac to the power of 2 over 4a squared, and that would be b minus b squared minus b squared plus 4ac over 4a squared. Wait, 4a squared, and this goes away. This also goes away, and then this also goes away, and then you get c over a. And that's pretty much it for the theory. For the rest, we have solving polynomial equations in technology. So you literally just insert it in the GDC and you get the results. And then solving other equations in the technology is also the same. You can either like insert the polynomial, or you can just draw a graph and then look for the like the points that goes into the x-axis. Or for example, like if you have this kind of graph or whatever kind of graph, just look for the points that crosses the x-axis, and that's the answer. And then this is just, I guess, an extra bonus because we don't really need to remember all these, but the typical a plus bx equation is called linear, and then the ax squared plus bx plus c is quadratic, and then the ax power of 3 plus bx squared plus cx plus d is called cubic, and then if you have to the power of 4, that's quadratic, and that's pretty much it. You don't have to like memorize it. As long as you can identify it when they ask you in the questions, that's fine. Clear. Okay, so the meeting's gonna end in about like a minute. So if you guys want to do some practice questions, you guys can join in again after the meeting automatically ends because I don't have Zoom Premium. Yeah.